Assalamualaikum dan salam sejahtera to everyone, especially to our lecturer Sahirul Amri bin Kasim. So today I and my group will explain what is ordinary differential equation ODE. So before we start, let me introduce myself. My name is Aina binti Hadiah. My matrix number 33FTV25F1068.
My name is Fitri binti Azhar and my matrix number is 33FTV25F1084.
Assalamualaikum and hello everyone. My name is Siti Arifah Nurain binti Ahmad Azli. My matric card is 33FTV25F1074.
Hi, Assalamualaikum. My name is Siti Nufiti Syara binti Azhar and my matrix number is 33FTV25F1077.
So this is our list of content. First, we start with introduction on page 4. And then, we have types of ODE, order of ODE, and degree of ODE on page 5 until 7. And then we have a question on page 8. And then we have solution of the question on page 9 until 11. And then on page 12, we have discussion. And then we have conclusion on page 13. And lastly, we have reference on page 14.
First, what is ODE? ODE is ordinary differential equation. It's an equation that involves a function and its derivative with respect to one variable. It is used to describe how two quantities change over time or with another variable.
Today I will explain the types of differential equation. Differential equation is divided into two main types, which are ordinary differential equation, or we call ODE, and second, partial differential equation we call PDE. And ODE involves derivatives with respect to only one independent variables. For example, is dy over dx plus y equals 0. In this equation, the derivative is only with respect to x, so it is classified as an ODE. Meanwhile, a PDE involves derivative with respect to or more independent variables. For example, partial z over partial x equals partial square y over partial x square. This equation uses partial derivatives, which indicates that the function depends on more than on variables. Therefore, it is classified as an PDE. So next, I will explain the order of an ODE. The order of an ODE is determined by the highest order derivative is the equation. The order is important because it helps us determine the number of initial or boundary conditions need to solve the equation. For example, dy over dx plus y equals 0. The highest derivative is first derivative. So this is called a first order differential equation. Second example is d square y over dx square plus dy over dx equals 0. The highest derivative is second derivative. So this is a second order differential equation. So I will explain the degree of an ODE. The degree of the highest order derivative, provided that the equation is in polynomial form. Before determining the degree, the equation must be simplified so that there are no radicals or fraction involving the derivatives. For example, d square y over dx square all raised to the power of 3 plus dy over dx equals 0. In this equation, the highest order is the second derivative. The power of this derivative is the 3. Therefore, the degree of the differential equation is 3.
Next, I will explain our question. For this question, we are given an investment account where the amount of money increase at a rate proportional to the amount of money present at time t. This means that the more money in the account, the faster it grows. So this equation follows an exponential growth model. The question is divided into 3 parts. For part A, we are taught the amount of money doubles in 5 years. Based on this information, we need to determine the annual growth rate of the investment. Next, for part B, the initial amount of money is around 2,000. Using the growth rate from part A, we need to find how much money will be in the account after 10 years. Lastly, for part C, we are asked to determine how long it will take for the investment to grow from RM2,000 to RM20,000. So overall, this question is focused on applying exponential growth in an investment situation to find the growth rate, future value, and time required for the investment to reach a certain amount.
We are given that the rate of change of the amount of money is proportional to the amount of money itself. So this can be written as VA per DT sama dengan KA, where A is the amount of money and K is a constant. So for the step 1, we need to solve the differential equation. First, we separate the variable. 1 per A dA sama dengan K dt. Next, we integrate both sides. So ln A tolak KT plus C. So we rewrite in exponential form. So A kurungan T sama dengan A naught exponential KT, and D is the exponential growth model. So next, we go to the question 1. So part A, we are told that the amount of money double in 5 years. So A kurungan 5 tolak 2A naught. So sekarang we substitute into the formula. 2A naught tolak A naught exponent 5K. And divide both side by A naught. So 2 sama dengan exponent 5K. And now we take natural logarithm. So ln 2 sama dengan 5K. So K sama dengan ln 2 per 5. So the value of K is approximately. So K is 0.1386 per year. Now we go for the part B. For part B, we want to find the amount after 10 years. So the initial amount is RM2,000. So A kurungan 10 tolak 2,000 exponent 10K, and then we substitute the value of K. So A kurungan 10 sama dengan 2,000 exponent 2 ln 2. So 2,000 kurungan 2 kuasa 2 sama dengan 8,000. Therefore, the amount after 10 years is RM8,000. Now, we go for the last part. For part C, we want to find the time when the amount become RM20,000. So, 20,000 minus 2,000 exponent KT, and then we divide both sides by 2,000. So, 10 equal to exponent KT, and then take natural logarithm. So ln 10 equal to KT. So T equal ln 10 per K, and then we substitute the value of K. So T equal to 5 ln 10 per ln 2. So the answer is approximately 16.6 years. So in conclusion, for part A, the growth rate is 0.1386 per year, and for part B, the amount after 10 years is RM8,000, and last for part C, the time required to reach RM20,000 is approximately 16.6 years. So that's all.
Let's move to our discussion. In this study, ODE was used to analyze the relationship between a function and its rate of change with respect to a single independent variable. Through solving the differential equation, it can be observed that the behavior of the system depends on the given parameters and initial condition. The solution methods applied, whether analytical or numerical, provide a systematic way to obtain accurate results and better understand the behavior of the model. The findings shows that ODEs are effective in representing real-world phenomena such as population growth, motion, and engineering systems.
In conclusion, ordinary differential equation or ODE are very important in solving and predicting real-life dynamic systems. Through this study, we learned that different solution methods can be applied to obtain accurate and efficient results. ODE is widely used in science, engineering, and many other fields, making it an essential mathematical tool. Thank you. So this is reference for our presentation. First and second point is YouTube link from Madam Hazwani channel that her student explain what is ODE. And then the third point is question from ChatGPT about ODE. So if you guys want to watch the video, you can click the first and second link. And then if you guys want to answer a question, you guys can click the third link. So that's all from us. I hope what we explained is clear and you guys get understand what is ODE and how to solve a question of ODE. Thank you.